Hello, in this video I'm going to look at the arc length of a function. So when it comes to arc length of a function, we take a curve y equals f of x and we look at the closed interval from a to b, and we actually basically cut those up into n pieces, of which we have n plus 1 points but n subintervals. But in either case, we can see that these red lines along here represent these little triangles, of which essentially you're just going to use Pythagorean theorem. So let's actually look at something like that, just to get an idea. Now, in this case, we have that delta x is going to be down over here. So we have delta x, but then we have also our delta y. Now they do give it like a little subscript k, and in any case, this is going to be the distance. Well, accordingly, the distance is going to be equal to the square root of delta x plus delta y. So delta y, and then sub k. Now, if we factor out the delta x, we basically end up with the following. And yeah, this should be squared and squared. So if we factor out the delta x, we're going to end up with 1 plus delta y k divided by delta x, and that's going to be squared. And we have that on the outside, that's delta x. So the measure of the arc is going to be approximately equal to the series summation k equals 1 to n, where we take the square root of 1 plus delta yk over delta x, and all of that squared times delta x. But we can actually refine this to where we take the limit as n tends to infinity. So if we take it to infinity for the length, which is the series summation from k equals 1 to n, of the square root of 1 plus our delta y, there should be a delta right there, divided by delta x, and that's going to be squared. And then, of course, we have that the delta x is on the outside. Now, all that this gives us, or what it does give us, is that it's the integral from a to b of the square root of 1 plus f prime of x squared dx. Now, you may wonder how, in fact, we went from delta yk to delta x divided by delta x to the derivative. Well, in Cal 1, you learn that essentially if you take the delta x and to take it to 0 for delta y over delta x, essentially that's going to give you the derivative function at some value x. But to be a bit more precise, we're actually also utilizing that the mean value theorem tells us that for any closed interval, in this case, it's going to be a, b. You have that f prime of c equals to f prime of f of b minus f of a divided by b minus a, which of course you're doing that for a subinterval xk minus 1 to xk in either case. But, either way, we get our formula, which here it is, and we can use it for any problem that we wish. Let's try to find the arc length of the following equation. So let's say that we have y equals to 3/2 x to the 2/3. And here we're going to look at it from 1 to 8. So let's say that we look at this equation from 1 to 8. So accordingly, we just have to find the derivative, which in this case would be, let's see, you have 3/2 multiplied by 2/3 x to the negative 1/3, which is equal to basically 1 over x to the 1/3. Now, we know that we have to square it, which in this case gives us 1 over x to the 2/3. But we also have to add 1, so 1 plus y prime squared equals to 1 over x to the 2/3 plus 1, which in this case would be x to the 2/3 plus 1 divided by x to the 2/3. Now, we have to take the square root, though, also. So if we take the square root, this gives us the square root of x to the 2/3 plus 1 divided by x to the 1/3. Now, when we set up our integral from 1 to 8, we have that essentially you get x to the 2/3 plus 1 divided by x to the 1/3 dx. Now, what this does for us is that it tells us that we can solve this using u substitution. So if we want to use u substitution, we can say that u equals to x to the 2/3 plus 1, and that du equals to 2/3 x to the negative 1/3 dx. Now, notice that pretty much this is exactly what we have in the denominator. We have x to the 1/3, because we notice that if we rewrite it, we have 2 over 3x to the 1/3 dx. Now, in any case, that tells us that all that we need to do is just basically multiply by 3/2. So we can do that. We can say that this is equal to 3/2 the integral, but notice that we can change the limits of integration. So for example, when x is equal to 1, we have that u is equal to 2. But when x is equal to 8, then that means that u is equal to 5. So we have that we're integrating from 1 to 5. Not 1 to 5, actually. It's, let's use 2. Yeah, that's a 2, right? So that'll be 2. And that's the square root of u du. Now, in any case, how do we do this? Well, we use the fundamental theorem, which says that 3/2 will be multiplied by u to the 1/2 plus 1 divided by 1/2 plus 1. All of this is evaluated from 2 to 5, but notice that in any case that the 3/2 would cancel out because it's 3/2 times 2/3 multiplied by u to the 3/2 from 2 to 5. Now, what that does is it gives us that the answer is 5 root 5 minus 2 root 2. And then that would be it with respect to the arc length. Now, if in fact we were to, for example, try to find the arc length of another equation, such as like if we have y equals to 1/2 x squared plus 1, and we want to look at this from 0 to 1, then we can actually find the derivative, of course, which in this case would just be x. But if we square it, then in that case you have that y prime squared equals to x squared. Setting that up in terms of the arc length basically would give you the following: the integral from 0 to 1 of the square root of x squared plus 1 dx. Now in this case, this integral at the moment cannot be solved by conventional methods that you've learned so far in Calculus 1 and leading up to this point in Calculus 2. What we would need to do for this one is we would need to use what is called a trig substitution. But at the moment, we can actually just leave it and probably just use a calculator to figure out like what this would be equivalent to. However, you can actually go ahead and form a partition from 0 to 1 and then just use that, like delta x is equal to 1 minus 0 divided by n which will be 1 over n, and then just choose a point between 0 and 1, or your subinterval, like midpoint, left point, etc. And essentially that would give you approximately what the measure of the arc happens to be. Now, if we go ahead and we use technology, we'll actually find that the arc length is approximately 1.1478. And once we get to using trigonometric substitution, we can actually figure out like what this is equivalent to. Now, we can actually, also apply, our arc length formula to similarly, like if we have g of x is equal to x cubed divided by 6 plus 1 over 2x, and then let's say that we integrate this, not integrate, but we find the measure of the arc from 1 to 2. Now, of course, you know that you need to find the derivative, you need to square it, but then you also need to add 1 to it, and then you need to evaluate it from 1 to 2 in terms of the integral. So that'll be something that you can do, which that won't be too hard, because we can find the derivative, of course. Like if you find the derivative, it's going to be 1/2 x squared, and then you're going to have minus 1/2 x to the negative 2. Of course, if you want to, rewrite this as 1/2 times x squared minus x to the negative 2, you actually can do that and then just square it and add 1. But notice that if you do find the square root of this equation in either case, like if you find like what is g prime of x squared plus 1, you're actually going to find that the equation becomes basically once you square this and then you add 1, essentially you're going to find that it's going to be 1/2 x squared, but then it's going to be like a plus x to the negative 2 divided by 2. Okay, so in any case, go ahead and check that out and see if you can find the arc length of this curve from 1 to 2. And finding the arc length, you're going to find that once you set up your integral from 1 to 2, and you have the x squared divided by 2 plus x to negative 2 divided by 2, and that's dx, you're going to find that this is going to equal to 17/12. Of course, like we can say that that's going to be whatever units that we are using, but since it's not really specified, we'll just go ahead and just leave it as like 17/12. But if we do have some units indicated, like if g of x was in meters, then it would be 17/12 meters in either case.